over the course of the year as we go through the MassBridge program, and I'll talk about that at the end of my presentation. To get us going, I just want to do a couple of quick housekeeping notes. As we go through the presentations this morning, if you do have questions, we ask that you put them into the chat during the presentation. My colleague Farhad Vazigu, I just killed your name there, Farhad, sorry, will actually queue those questions up as we go through after each presentation. We really want to create a lot of conversation in today's meeting and really open up this discussion around what we're trying to do. We also have set aside 30 minutes at the end of today's program to really go into a much deeper dive around the MassBridge program and the needs of what industry is looking for, so that can help us as we develop our curriculum. And last but not least, throughout the meeting today, we'll be queuing up a couple of poll questions. I do ask that when those poll questions come up, if you'll just take a moment to actually fill them out for us, that again helps to kind of direct our conversation as we're going forward. With that, I will queue up my presentation and we'll get going.
So for those of you, you can see that we are recording the session.
Thank you, Farhad.
Yeah.
All right, with that, let me get us going. So for those of you who are not, who do not know me, my name is Megan Abella Bowen. I am a senior program manager at the Massachusetts Center for Advanced Manufacturing at Masstech, and I'm one of several of our team members who is involved with working on the MassBridge program. And so I have the honor today of giving you a kind of a high-level overview of the MassBridge program, and then each of our other presenters will give you more details around the Manufacturing USA Institutes, and then also the findings that have been that we've been doing through this program. So first off, as our name implies, the MassBridge program is bridging the gap in manufacturing technician training. And to do that, we have three key elements of the program. Today, we're going to really focus on this first bullet, but I do want to make you aware of the other two bullets because they all tie together nicely. And first off, we are developing a state-based training and career pathway model for technicians that are going to span what we think may be some of the gaps that are existing in our current statewide advanced manufacturing programs, and also will tie to the Manufacturing USA Institutes, and I'll talk about those briefly in a moment, and also about all the other training programs that we have. So that's the overarching goal. But there's the other side of the equation is actually about creating awareness around careers and jobs in advanced manufacturing, getting students really engaged in this idea. And so we are focused on it from a perspective of we want to create an awareness module that is tied or focused at the high school level and community college level. And that awareness module is really going to create excitement around the technologies and the applications in advanced manufacturing, as well as the careers. The second part of it is then developing a marketing campaign to promote these types of careers. And again, the education and training that is available out there. If we can develop a really well thought through curriculum and program, but if we don't really sell that to people and people aren't knocking at the door to take it, it doesn't matter what kind of programming we do. So those two pieces of the equation are very important. Next, I'm going to get into a deeper dive about the MassBridge program. So kind of the first piece is, this is a program funded through a Department of Defense Manufacturing Technology Program grant. And as I mentioned before, its real kind of goal is to create this statewide training program or training system with the potential that our model could then be a model for other states across the nation. And what we did here, and why Mass, it's because in Massachusetts, we actually have a very well coordinated system already in place, working collaboratively together. Kelly mentioned that with the Mass hires and the things we are doing across the state. Our community colleges work very closely together, and our vocational system. So that's part of the reason for why Mass. And what we wanted to focus on are, in this particular picture, is talk about the types of training we're discussing, highlight a little bit on these institutes, and then tell you what we're focused on in this level 3. So if you look at level 1 and level 2, these are the manufacturing foundational programs that are currently existing across the state. And these cover things such as basic job training and traditional manufacturing. And these might be the kinds of skill sets that you're thinking of shop math, blueprint reading, CNC machining, and introduction to programming would fall in some of these areas, among other things. And we feel like we have this pretty well covered with our vocational programs, our advanced manufacturing training programs that we have at the state level through Mass MEP, and also with our community college programs, certainly in advanced manufacturing and engineering technology. As we go up into level 3, these are what we kind of are focused on as those middle skilled jobs and those middle skilled competencies. And these could be those types of skills that might fall under, if you're thinking systems thinking, troubleshooting, process planning. And we also feel like these are the kinds of skills that transfer across numerous sectors of advanced manufacturing. They're not tied specifically to a single institute or to a single sector. And we feel like our community colleges are doing a good job here, but we think there's gaps in some of our programming that mean that when individuals come out of either our community college programs or some of our other training programs, maybe they're missing pieces of the pie that make it easy for them to segue into your company and start hitting the ground running, or they continue on with additional education. And again, there may be gaps that force them to have to go back and redo some things in order to be able to get through. So we're really trying to understand where those gaps are and how we can better prepare our students and individuals to be able to be ready, job ready, and continuing on with their education. And then last but not least, we have level 4, which really gets into those specialized careers and specialized training around specific institutes and around specific sectors. And for Mass, we have focused on 6 of these Manufacturing USA Institutes. And so the Manufacturing USA Institute is the umbrella organization. There's 15 specific institutes that fall underneath that umbrella. And the Manufacturing USA is really focused on how do we improve competitiveness in manufacturing. And so Mass has been focused on these 4 institutes specifically, and I'll go over them in a little bit more detail, and we're picking up 2 additional ones as we go forward. But we focus on, because they tie closer to our industry, AIM, which is Integrated Photonics, ARM, which stands for the Advanced Robotics for Manufacturing, NextFlex focuses on flexible hybrid electronics, AFOA, which is functional fabrics or advanced fabrics and fabric technology, 3D additive manufacturing under America Makes, and LIFT, which is focused on lightweight materials. Again, we'll go into a little bit more detail about AIM in particular today as one of the institutes that we're working with, but this just kind of shows you this path that we're looking to build and where we think there may be gaps and where your feedback as industry today is really going to be key. So the defining of the curriculum is, how are we going to do this? How are we going to build this curriculum? And the curriculum is being built utilizing 3 really key guiding principles. First off, as we started, we said we need to really understand what already exists out there. We don't want to duplicate things that already exist. We might elevate some things that may already be out there. So you're going to hear shortly from one of our colleagues who has been focused on benchmarking the curriculum, not only here in the state of Mass, but also nationally, and what's happening, what are maybe some best practices out there. The second piece is understanding the workforce roadmaps, or really what are the workforce skills and competencies that companies are needing in these advanced manufacturing fields. And so we have a colleague who is focused on surveying and interviewing companies that are tied or have a connection with the types of things that the technologies that you see in those institutes that I highlighted earlier. From that, we're then now coming to the industry-driven part. We need to really focus on what are the needs of industry. We want to make sure that we are responding to that in the development of our curriculum. Once all that happens, we then are going to go over and use that information to develop that awareness module I alluded to earlier, which is really around creating that excitement for the high school level students. But the credit courses or the community college courses will focus on that data and figure out where we have gaps and see how we can approach filling those gaps. And then just kind of a high level flow of how this is going to take place. This is a 3-year program. We are currently in year 1. And again, as I just touched base on before, we have been spending the fall and the first part of the winter really dealing with the curriculum benchmarking and the workforce road mapping of 2 of the institutes. We'll continue doing the road mapping throughout the rest of this summer to focus on the other institutes. And then now we are pulling these forums together with our industry partners to provide some of this initial findings and really ask for your feedback. Are we hitting the right things? Are we on target? Or are there still pieces that we're missing? We really want that feedback and your validation on what the information is that we've found so far. Once we have all of that, we will be passing this information over to our community college faculty and our curriculum development team. They will really take that information, they will utilize it to explore what we already have and figure out how might we develop training and develop our curriculum to address those gaps. In addition, we will then be piloting that program. So they'll be spending the next 4 to 5 months, basically from now through the end of the summer, developing the curriculum. They will pilot that curriculum next fall at 6 of our community colleges. And then again, at the end of the first semester, they'll come back, they'll look at that curriculum, and we'll do lessons learned, an evaluation. We'll again run courses in the spring semester, again come back in lessons learned. But during this whole process, we're going to include industry back around the table for discussion to say, here's where we are with the curriculum. Is this meeting your needs? Are we on the right track? Get that feedback. So we see this as an iterative process, not a one and done. And we're hoping that, again, you will engage with us throughout the course of the process with us creating the curriculum. In the third year, that's where we will be deploying the programming statewide, and also be now having conversations with other states who may be interested in the training program. With that, that kind of gives you the big picture overview of what we are doing in MassBridge. I know it's a very quick presentation, but if you have any questions, I am happy to take those. And if not, we can queue up the first survey. And if folks will go ahead and answer the survey. All right. How are we doing on the survey, Katie? You're on mute.
How have I not learned by now? Still getting input, maybe a few more seconds.
Okay. And then with that, I have stopped sharing. Anu, if you would like to go ahead and bring up your presentation, and I will be passing it over to Anu. Anu is going to do a presentation on the AIM Institute and give you more information on what they are doing around workforce development. And with that, Anu, I will pass it on.
Thank you, Megan. Can you see my screen?
Yes.
Okay, great. Good morning, everyone. My name is Anu Agarwal. I know some of you and some of you know me. I'm very excited to present the work that we're doing at AIM Photonics Academy, which is basically education and workforce development. And it is for AIM Photonics Institute, which resides in New York. The growing AIM Academy Toolkit includes education, workforce development, and also road mapping. In education, we have a summer academy, online education, virtual manufacturing lab. Under workforce development, we offer boot camps through what we call LEAPS, which is our labs for education and application prototypes. And I'll talk a little bit more about that. In road mapping, there's education roadmap and technology roadmap. I'll talk a little bit about the technology roadmap, and you'll hear about workforce road mapping from my colleague today. The boot camps are basically in-person hands-on training about integrated photonics through the Massachusetts LEAP network facilities. We offered one in January, and we hope to offer more once COVID has finished. edX courses are being offered. Some of them have already been done, and some are in the pipeline, due to be offered even as early as next month. All of these courses and hands-on training that we offer include simulations from the virtual manufacturing lab. And these simulations, you can see snapshots of them, screenshots of the simulations. They help to build intuition about what integrated photonics actually is. And I'll talk a little bit about this one simulation that shows the waveguide bend. In terms of road mapping, there's the education roadmap, which talks about skills, levels, and how do you deliver this educational package to people so that it's most well received. And we'll talk about that in MassBridge, of course. The technology roadmap is what I'm going to say a little bit more about in my talk. And this deals with what kind of components are in the pipeline coming through the technology pipeline, and how should companies be ready for it? What supply chain is needed in order to make more of such products? So in terms of photonic integrated circuits, basically what are they? Several of you know about this, but they're manipulation of light on a chip. Here's a spiral, a Y-splitter, a Mach-Zehnder, a ring resonator. So all of these photonic integrated circuits are applied to AIM technologies. And these technologies are basically 4 of them. Datacom, telecom, we're very familiar with. RF communication through free space. Chemical and biological sensing, LiDAR for self-driving cars. All of these photonic integrated circuit applications need photons. And photons are different from electrons in that the behavior of light at bends is different. So I'll run through the simulation very quickly. It's a bend, a waveguide bend. And here in this box, you can see the loss that's emanating from this bend. As the bend becomes less and less sharp, which is the radius increasing, less and less loss is seen here. As you make that bend sharp again, you see there's more loss in this case. When you change to a transverse magnetic mode, the loss is a lot higher. So we build this intuition about bends. We also show that when you change the waveguide width, for example, and making it narrower at this bend, you see more loss. So as the width changes, as the bend sharpness changes, you see that there's more or less loss. So it's very geometry dependent as opposed to a straight wire or on an electronic chip. And this is how we build intuition with our students. All of this is used in our hands-on training as well. Through the Massachusetts LEAP network, we have here the LEAP at Massachusetts, at Worcester Polytechnic Institute, and Quinsigamond Community College, also at Bridgewater State University, at Stonehill College, and the newest one at the Western New England University. Through all of these LEAPs that are shown here, all of them were funded by the Commonwealth of Massachusetts through Masstech Collaborative. And the idea is, can we be a center for innovation and prototyping for local industries in the space of integrated photonics? So we welcome partnership with industry in order to use these LEAP facilities for next-gen innovation. Here's some vignettes from our hands-on, very successful bootcamp offered in January last year. We'll offer more of them, as I said, as the year progresses through several LEAPs, not just the one at MIT, which started it out, but we hope to spread it out across all the LEAPs. More teaching and collaborating is happening through the LEAPs. There's MIT and Springfield Technical Community College. You can see the MIT student and Springfield faculty talking about problem-based learning challenge on PIC sensing. BSU and Stonehill are building a 15-month photonics technician training program. BSU is offering the first ever photonics engineering undergrad program. WPI uses these LEAPs in their major qualifying project. So next-gen innovation, again, I stress, is happening right here through these LEAPs, through industry and academic partnerships, through summer internships. We use the simulations to teach about learning in an application such as sensors. So the sensors application game teaches students to design optical circuits that detect gases, molecules, biological substances, and so on using light. And just as in any game, there are many levels. So we start with level 1 and we slowly build up to level 5. And in each level, we teach about a different concept of integrated photonics. Here's a screenshot of a game. It's a development in progress, so it's still being completed, this game. It should be ready by June. Now, in the technology roadmap, as I promised, I'll say just a little bit about sensors again. What does the technology roadmap look for PIC sensor integration, which is photonic integrated circuit sensor integration? And one of the reasons why we have to do this is we have to understand where we are and where we are going. We are here right now with hybrid flip chip bonding. In 5 years, we may be monolithic. In 10 years, we hope to have high density, multi-level vertical packaging. In 10 years, we want smart sensors with full readout circuit integration. So what is missing? Companies can go away knowing that on-chip power supplies are needed. Should they be battery? Should they be solar or other ways to supply these chips with power? Multiple wavelengths are desired. Sources can be UV, visible, and so on. We need detectors. Polymer photonics is also desirable for the next generation. So these are what we do through the roadmap, technology roadmap, is identify required future attributes and let companies and academia work together to develop them. And I'll end right there to say we're doing all of this through AIM Photonics Academy, which is a part of AIM Photonics Institute.
Thank you, Anu. Julie, will you be adding anything, or does that cover the whole presentation?
I think that covered it. I did Julie's part too.
Oh, great. So do we have any questions?
I will just say one thing, which is we do have this technician program at Stonehill and BSU. If any companies are interested in hiring technicians, they will be available this coming summer. So we would love to work with all of you.
Great. All right. With that, then, we're going to move on, and I'm going to bring back up my slides. And we are going to pass it over to, oops, sorry, there's everybody. And we are going to pass it on over to George Westerman now to talk about the benchmarking, the curriculum benchmarking study.
Great, thanks, Megan. You know, one of the great things about being at MIT is how closely the different groups work together on these different topics. So, you know, you have the IKIM group before and after me, and also I'm with the Office of Open Learning here at MIT. And we collaborate on these projects all the time, and that's how these wonderful results are here. And the AIM Photonics group has been fantastic for really pushing the envelope on the kinds of learning that's out there, and for this engagement with industry. I've been just so impressed in working with the IKIM, the AIM Photonics group here. So one of our roles here, so I run workforce learning at our Office of Open Learning. So we're thinking about how to restructure and how to improve the way that people get skills for work, or that workers get additional skills in their careers using the right combinations of digital and physical and hybrid work together, and new techniques to make that learning happen. So what our job was, at least in this first part of the project, is to benchmark the existing curriculum. Where are these skills being taught? And if we were to think about those levels that Megan talked about, what would be in each of those levels, to look at it in a very systematic way? And then how can we deliver those pieces? So next slide, Megan. So as Megan said, we're really looking at that level 3. It's above the traditional, but it's not all the way up to teaching every single one of these technologies. It's trying to teach those transversal skills, those systems thinking kinds of skills that will make you better at any of those more advanced elements. And the idea is, if we can train it, there's less that you have to do in companies when the employee comes to you. So next. So we built a database of associate's degrees and certifications and competency models in the 6 areas that Megan talked about, each of the institutes. We also interviewed 26 organizations, from schools to employers to credentialing companies, to get an idea of specifically what competencies are in these curriculum, or what competencies are being demanded by industry as indicated by these credentialing efforts. Next slide. And it's a nice long report, 100 pages if you want it. We're finalizing it now, but we'll be happy to share with you in a couple of weeks if you want to see all the detail in here. I'm going to focus just on these 2 yellow levels in the next 5 minutes. So what we did with our database and our more quantitative analysis of these skills is we gathered up curriculum and certifications and then put them by levels in these 3 levels: the manufacturing technician, the advanced manufacturing technician, and the specialized. And then what we did is we tried to identify what are the core skills either being taught or demanded by the certifications in those areas, so we can characterize what ought to be taught at each level. And certainly there's work on integrated photonics. As Anu talked about, we could incorporate that curriculum in here. Some of the other ones, especially additive, especially flexible electronics, functional fabrics, there aren't yet full courses out there, not full degrees out there, so we're going to have to augment the information in there. Next slide. So you can't read this slide, but I just wanted to show you the patterns we're seeing here. What we see when we look across the curricula is a set of skills here on the left that are those core skills that you need just to know about manufacturing. In this middle section are the skills that are more advanced, and I'll tell you what they are in a minute, and you can see them in the brown and the purple, these more advanced programs. And then on the right are the most advanced ones, the things that are really going to get you up to that level, start preparing you for that level 4 as opposed to being an advanced traditional manufacturer. So if you flip the page, we can walk through what these things are in detail. So for example, the core skills, and Megan talked about some of these already, the foundational skills that we feel that the Massachusetts community colleges are teaching really pretty well are CAD/CAM, blueprints, safety, quality, basic reading and shop math. These kinds of things are pretty well covered. If you can click again. Now this advanced level is what we're hearing a lot of people asking for, and some programs are teaching it, some aren't. But if we were to characterize what gets you from the traditional to the first step of more advanced, it's this the ability to think about systems, to think about quality as a system, not just what you do to maintain quality on your side. Think about troubleshooting and running, troubleshooting and maintenance, right? So it's less about working on the line and more about understanding the line and how to improve the line if things happen. And then the next level is for working with those more advanced technologies. Now we get the systems thinking, the optimization, the probability. So automated systems and computers, data management, then you get into simulation and probability and stats. This is that more advanced. This is the technician that really can help to continuously improve and to implement new production technologies, not just use or troubleshoot the ones that are out there. And as we think about the level 3, the curriculum that we're going to try to train here in MassBridge, we're going to focus on this middle and the rightmost. We're going to make sure those left things are there, but where the new work to be done is in these ones, the middle and the right-hand side. So next page. So as we're thinking about it right now, so that's one thing you can think about, by the way, those skills. How well do those skills line up with what you need in your organization? We did that poll. We can come back to that. Are you looking for somebody to do the work, somebody to troubleshoot on the line and understand the line, or somebody to actually help you improve the line and implement new ways of working over time? As we think about this curriculum, we are right now working with the curriculum team to think through some options, whether it be plug-in modules, would it be a 3rd year instead of a 2-year, or other different combinations. That's for the curriculum team and us as a group to figure out. And then the very last slide here, we also have a number of recommendations based on our interviews. And these are interviews with some really exemplary schools in Ohio and in Indiana and Tennessee and, other learning we've done from Florida and other places. There are a lot of recommendations in here, but when we think about the recommendations that really link closely to you, as the employers, one is that we really want to emphasize the why and how, not just the what, right? Not just what to do, but why you're doing it and how to make it better. We want to make sure that there's a work component in these efforts. And so as you think about internships and apprenticeships, formal or informal, how can you work with us to train these students before they get out? It's really worth thinking through industry recognized credentials, because these credentials do 2 things. One is they allow employers to understand what people really know as opposed to what they learned in a classroom. But number 2, these credentials allow the students to gain skills and get recognized skills and potentially even improve their jobs while they're in training rather than waiting till they're getting out. So we can talk about credentials and how much these credentials matter to you and which matter. We're certainly trying to talk about underemployed and incumbent workers, not just the new entrants, because the pipeline will not be filled by only the new entrants, even if we're completely successful with our outreach efforts. I want to emphasize human skills, and these human skills go beyond the ones that we hear from employers. Certainly, yes, you want them to show on time, you want them to be respectful, you want them to focus on their work, you want them to collaborate well in teams. But there are other human skills, the critical thinking, the systems thinking, the comfort with ambiguity, the ability to change, the ability to lead teams that are not emphasized in programs now. We want to really think more about how to do that. And then 6, certainly a lot of leverage of technology. But last, these programs work well when they are planned in collaboration with industry, when industry people allow these students to come in and get hands-on experience as they're training, not just when they graduate. And when the community colleges can also work together to coordinate the programs so that so that they can get the leverage on what they're doing, and you can understand, no matter which school in the system that somebody came out of, you understand how well trained they are. So from what you can do to help the students as they're training, to how you can work with the community colleges to make sure these programs work better for those community colleges and for you, these recommendations can be helpful. So certainly we would be happy to share the report with you, happy to talk more here, but we'd love to engage with each of you to make sure that we can make MassBridge work for you, so that when the students come out, they're ready for the jobs that you have for them. Okay, thank you. Any questions on that?
All right. Well, with that, because we want to throw up our next poll question that is actually asking about industry credentials. So if you would take a moment to respond to that. Katie, are you also able to show the answers once we're done with the?
Yeah.
Okay. And maybe before we go into our next presentation, can we show the answers to both of them?
Sure. Need a few more on this one.
Okay. And I just give it just a couple more seconds, because most of us, we're a mix of educators and industry. So us educator folks are probably going, we don't make those decisions. All right, go ahead and close it.
Okay.
And can you show the answers, the responses to that?
You want to do first one or second one?
Can we do both real quick, just to kind of see
Yeah.
how people were talking? That will lead into the next discussion.
So this is poll 1. Can you see that?
Yes.
Okay.
All right. So it looks like we have, it kind of mixes. So it's a really interesting piece. We've got 44% on that entry level and also 44% on the manufacturing technician. So very interesting. And the second poll, please. All right. So again, interesting piece, but this is a conversation we'll continue on during the 30-minute discussion, because we have been hearing different things about certification. So that's very helpful. Thank you very much. All right. With that, again, if we don't have any questions, we will pass it over to Randy, and Randy will give us an update on his findings.
Thank you, Megan. So again, my name is Randy Kershane. I'm a principal research scientist here at MIT, and I'm part of a team of folks that have been looking at this question looking at the topic of workforce road mapping. So if you go to the next slide for me there, Megan, just to kind of define for you what we mean by that. Essentially, what we're trying to understand is what are the workforce needs for advanced manufacturing. That includes both what types of workers are needed, how many of those there are, for those, which of those positions are increasing in demand, or most difficult to fill, or require the most additional training when you hire them. And then around that topic of training, what specific skills do these workers need? And then kind of an important aspect of this is what is changing. And so the scope of what we've been looking at here are the industries are focused around the institutes that were mentioned earlier. And today I'll share with you some of the results we've had around photonics. We've been looking at technical skills in particular. And so I want to emphasize the point, or reiterate a point that George made just a moment ago, which is that in doing this, we're not at all implying that the human skills are not important. We needed to scope the activity in some way. And these were things which clearly would influence curriculum decisions. We've focused on middle skilled workers, although for photonics in particular, we included a few particularly unique lower skilled occupations as well, things like semiconductor processor or electronics assembler. And for the photonics survey, we have looked nationally. For the subsequent surveys and the ones that are ongoing, we are focused on New England and particularly around Massachusetts. So if you go forward for me. So a couple of additional quick definitions, just so you know what we're talking about. Middle skilled worker here, we mean someone that has training beyond a high school diploma, but typically less than a bachelor's degree. So an associate's degree is sort of a typical version of that. Middle skilled job or middle skilled occupation is a position that is predominantly filled by workers that meet that definition. In terms of technical occupations, if you go forward for me, we are covering all of these things that are classified here, but predominantly I tried to bold the ones that are most represented in what we're talking about in these industries, which are engineering related jobs. So engineering technicians in particular, individuals in the physical sciences, technical personnel in installation, maintenance, or repair occupations, technical production occupations, and if it comes up, mathematical operations. The most relevant thing is to note that we are not covering IT workers, even though there are a lot of middle skilled workers in those positions. And that's because from some early interviews, we identified that there weren't any particularly unique skills needed for advanced manufacturing for IT workers. And there are a number of other studies that have looked at that. So that's kind of our focus in terms from that perspective. So if you could go forward for me, how have we been trying to answer these questions? Well, we've been trying to answer these questions by talking to folks like yourself. So in particular, we've developed a survey and now interview that we try to collect. We try to ask exactly the questions I posed just a moment ago, plus a section that helps us to understand for each firm what kind of firm that we're talking to. So the size of the firm, where they sit in the supply chain. We ask about which of those positions are challenging in one way or another in terms of hard to fill or need training. And then for a select number of those, we do deep dives to better understand those skills needs and how they're changing over time. And if you click forward for me. So kind of shifting to what we've learned we have completed surveys and interviews for 2 of the sectors, photonics, which I'll focus on today, where we have a little more than 50 responses nationally where people have completed the entire survey. I just put in a little plot here to sort of show you where those responses come in the supply chain. So we have firms that have responded all the way from raw materials producers to tool and service suppliers, with most of the responses kind of coming in the middle, that is firms that might fabricate components or assemble those into systems in one way or another. We also have wrapped up, and I'll show you a little cross-sectional result right at the end, a set of interviews with fiber and fabrics firms across New England. And there's some interesting overlaps between their skills needs as well. If you could go forward. So what have we learned? We've learned 2 key things, or maybe really 3. Demand is strong. There are key training gaps for workers, and we can identify what some of those gaps are. So if I come to the first point, we see both in terms of responses around demand growth for positions, and also from some econometric analysis, which I'm showing here, that demand for middle skilled workers in the photonics industry is quite strong. Our analysis would suggest more than 20,000 openings cumulative by over the next decade, essentially. That represents more than 500 openings. And I just want to, in Massachusetts, so I want to emphasize these are for these technical middle skilled workers. If we expand this to also include specialized lower skilled workers, these numbers more than double. There's more growth in the components part of the industry as opposed to in the fiber pulling and fiber assembly part of the industry. Strongest growth for photonics is around photonics technicians and a lower skilled position called optical equipment operators. And if you click forward for me. Oops.
Go too far?
Maybe, sorry. That might just have been you'll have to just go for it. Yeah, sorry about that. I'm not sure what that little glitch, go back and yeah, just leave it right there. Sorry. I'll pantomime that plot that's not there. Anyway, so if the plot was cooperating, what you would see is what respondents have told us are the positions that have the most, require the most on-the-job training once a hire is made. And you probably didn't see it long enough to be able to tell, but there were many responses that indicated that significant training is required after hire. And the 5 positions that I have listed here are the ones that would have been at the top of that plot with the most responses of that kind. So those are photonics technicians, electrical engineering technicians, that optical equipment operator, CNC operators, and semiconductor processors all have. I should also say that all of the positions had training gaps, or these are the ones that were most intense. So sorry about the plot there, but if
Megan, you can go off the presentation mode, and now you will see both of them, right? At least
yeah, okay. Sorry. Hopefully the rest are more cooperative. I apologize for that. But you can see the way you kind of read it is the more dark orange you see here, the more individuals responded that these are positions that have the need for extensive training. And then if we go on to the next one, we could probably try it back in full screen, but who knows, I might have messed that up too, but we'll see. See if the next one cooperates. You can click one more and see if the graph will come up. No. Anyways, what I would, so this is an example of the detailed skills analysis that we've done for each of the positions. I'm just showing you one of them here, which is the photonics technician. And it's not as important to see individual things here, but I just wanted you to understand that we did interview and survey about very specific tasks. So the first one that's at the top there is the skill to be able to fabricate and test devices such as optoelectronics or fiber optic based devices. When we look across not just this position, but other positions within photonics, we see some key challenges around, or some key gaps around being able to master those fabrication processes, to know about testing and data analysis. And so in the report that we're creating, we're trying to pull out what these themes are in terms of the skills that are becoming most important for photonics technicians. But as Megan and George talked about earlier, a key thing for the MassBridge project is to identify what are common skills needs across both the positions in photonics, but also across multiple industries. And the way that we're doing that, if we can, yeah, why don't we try it one more time? Sorry about the technical difficulties here. There we go. The way that we're doing that is that even though what we're interviewing about are these red, very detailed skills at the bottom of this plot, we have intentionally used skills that are part of an established skills hierarchy that allow us to map those specific skills into more and more general classes. And by doing that, we can look for trends in these classes, both across positions and across industries. And so if you go forward one more for me, what I'm showing here are the sort of top 5 of those high level skills categories when we consider both of the industries we've interviewed so far. So photonics on the right in the red, fabrics on the left in the tan. Now, there are some clear differences. If you look at that 4th one down there, thinking and making creatively, which includes those fabrication tasks, that was actually the most important one that came up across all of the positions of photonics. And you can kind of clearly see in fabrics, it doesn't come up as important. But overall, there are some key commonalities here. So analyzing data or information, so developing testing and assessing testing is an important skill across both of these industries. Troubleshooting is an important skill. Information management, which includes both being able to identify the right information and communicating it to others, is also an important skill. And so these kind of themes we feel are important for shaping that curriculum that George and Megan were talking about earlier. If you go forward for me.
We lost one, sorry. Let me just go back out, apologize.
Okay, it's fine. That, what I could, I'll just say that, so we've just begun the process of interviewing of setting up the interviews for the robotics industry, and we'll move on to the others. And what we'd love to hear from you all is when you kind of look at those types of skills, so analyzing data, troubleshooting, information management, are those skills that you feel would be relevant for technicians in your firm? Do these resonate with you as the kind of things that are becoming more important for those technical middle skilled workers? So thanks, and happy to take any questions And also, we are very close, as George said, on his part, to a report that we'd love to circulate and get your feedback on this. Thanks.
Thank you, Randy. Randy just gave quite a bit of information, so I want to see if there are any specific questions. We are actually going to use this question that Randy had posed to jump off into the next section, which is our discussion. So just wanted to put it out there and see if any of our industry partners had any responses to the data that Randy has just presented. All righty.
Very quiet group.
I know. So with that, then I'm going to hand it over to Farhad, and he's going to lead us through our discussion here this morning. And with that, I will switch over to this slide for you, Farhad.
Yeah, thanks, Megan. So first of all, thank you very much to all participants and industry forum representative as well. So industry representative, really appreciate the time you've devoted to attending this meeting. But I think as you can imagine and you agree that this is a critical need. We've heard from across the spectrum as to, access to talented employees. And today you've heard from, the Megan about the program that we have in Massbridge, what the scope of the program is, and you've heard from the road mapping and the benchmarking group. So what we are trying to do with these forums is really to get an answer, not just an answer, but to engage with you to make sure that we are on the right track. And what I've tried to do here with this, slide is almost put it as a challenge for us, is the training challenge. And the way we view it is really the training is split into two segments. One is what we call general training provided by either yourself or other institutions, or whether they are academic institutions or third party providing those or not. And then what on the right hand side is the specific training provided by the employer. What I mean is that this is particularly focusing on something that is really close and targeting your company, your applications, your product development, if you will. And so given the fact that, there are 7,000 SMEs out there in just Massachusetts alone, it's going to be very hard for any educational institution, let alone a sort of non-institution, to provide the exact training that you need. So we feel that piece of it in your domain. What we're focusing is on the left-hand side. The left-hand side is really what we've heard from the employers is that we are not giving the right training. People are showing up at your doorstep with not having the prerequisites, if you will. So you would have to do that. Basically, you're taking on that exercise, if you will. And that is something that we want to eliminate, because we feel that by eliminating that for you, by providing that, we're going to help you be more competitive, more nimble, and focus on things that matter to you. And quite honestly, the initial slide was really talking about the training cost, but sort of moved away from that. But really, one of the aspects is that the training of your prospective employer is an added cost, an added opportunity cost, added time and resources that you spend with that. So what we're trying to do is with the focus of Massbridge and the curriculum developments, develop what we feel that is effective. And by that I mean, it's not something that we're going to develop yet another curriculum given by some institutions, then you're just going to say, well, that doesn't hit the mark. And so really today's discussion and today's engagement with you, and continued engagement, I should say, is really to get an answer from you, say, what can we do to eliminate the left column here, which is really something that you're doing currently. So that is the picture I want you to have when we engage with you on several topics here. And so for the next 30 minutes, we're hoping that you can talk about some of the problems you're facing, some of the, in terms of talent acquisition, what are the areas that we need to focus on? Where are we going to hit the mark? What we shouldn't be doing, because as I said, we don't want to have another set of curriculum that doesn't address doesn't hit the mark. So with that, I want to stop at this point here and see whether what you're thinking about this picture. Does this picture resonate with you? Is there something that missing from this? What are your views? And it's really I know we've been very quiet so far. So I think this is an invitation for you to jump in and say something. And there is no right or wrong. I think this is a venue for us to debate and hear from each other. Okay. It sounds amazingly silent, but
it sounds pretty accurate from what you're going through. I mean, working in our industry, I don't work in photonics. I work for Boyd Technologies, who is a contract manufacturer of medical devices. But we do struggle with some of the training and getting people hired and making sure that they have the technical skills to troubleshoot and problem solve. And it's something that we really wish that we could, bring in people that already had these skills because of the high rate of turnover in our general industry as well.
Yeah. So Scott, may I ask, when these prospective employees show at your doorstep, I don't mean literally showing at your doorstep,
Sure,
but when they appear there, what are the gaps? What do you see? Are our institution are not teaching the right stuff, or we're not targeting the right population? What problem do you see there?
I think for our industry, we're often looking for more of a technical and almost more of a mechanical expertise. And that is not a skill set that typically comes with some of our lower end operators skill sets. We do have a lot of the basics, as we talked about, in sort of the phase 1, phase 2 approach, where they have the shop math abilities and the general manufacturing capability. However, when it comes to important aspects such as maintenance and troubleshooting, those tend to be additional challenges.
So, and I think this question will actually come back. I want to ask it now while we're actually in the midst of this conversation. One of the questions that are coming up is that, do you have a skills matrix, something that says we are looking for this?
We don't. We have very specific job descriptions and skill sets that we're looking for identified there. But as far as like a skills matrix or even any sort of analysis of those technical skills prior to hire is not something that currently takes place. That's a good idea, though.
You think this is a good idea?
I don't see how that could hurt.
Yeah. I'd like to hear from others who, on this topic. If
I have a question for Scott about that, just to follow up, Farhad, may I?
Yeah. Go ahead.
So Scott, that was really informative, that you have to train people on the types of skills that they need when they perform at the levels that you need in your company. Where do you envision this training would best come from? If you had a wand to wave and you said, I want them to be trained, where would this training come from? From the educational universities, your community colleges, or where?
Yeah, I mean, some of the challenge, when we look at like hiring some of our engineers, they're coming in with a lot of the mechanical background and communication skill sets that really suit our needs. I think our challenges are more posed from some of our maintenance and skilled laborers that are not receiving, you know, the full higher education. I think the presentation really highlighted that middle skilled, that operator, and that's really what we're looking for. And they're not always arriving at our doorstep, as you noted, with those technical skills. So whether that is occurring at like a 2-year college level or even in high school, that would really be the most beneficial for us.
So that's very interesting, Scott. What I focused on is that it's almost saying that the type of expertise or training that you require is almost coming in with somebody with a degree. So they've spent 4 years, and along the way they've attained those. Whereas what we need to be thinking, or at least that's what I'm hearing, is that there are attributes that are being taught in a 4-year degree course that we may be thinking that we need to bring them on lower in, you know, into sort of perhaps a 2-year associate or some technician training.
Ideally, yes, especially when it comes to manufacturing. I just don't think, you know, a lot of the technicians that even have interest in manufacturing are receiving that some of that skill set in the high school and, you know, technical college time period.
So just George, just to be clear, could you say again what are those skills that seem to be missing that you get in the 4 years that you aren't getting in the others?
Sure. You know, some of the areas that we, you know, I think we're really covered with the general kind of shop math, understanding how manufacturing works, and general operation of our equipment lines. But I think some of the challenges that we face are really some of the technical skills of troubleshooting, understanding the mechanics and general physics of how those equipment lines work, which I really noticed where you kind of brought in, I want to say it was kind of group 2 in that skill set, not all the way into group 3 yet, but some of those general skills in group 2, where I do feel like a lot of our operators are coming in with those group 1 skills already, as you noted pretty eloquently. But the group 2, as we transition into how to troubleshoot, how to problem solve actively on the equipment lines, would be really beneficial.
Wonderful, thank you.
I wonder how this resonates with our photonic industry representatives here. You know, any words from our photonic colleagues?
So I work at Opticos in Wakefield, and we are photonics. And the challenge that we're having is getting the skill set to come to us. We don't find many candidates that have any optics or photonics background. So I'm wondering if there's something we can work on to start partnering with when you have graduates coming out of these programs, to somehow direct them to our industry so that we can get more hires coming on board. When we post general ads, we don't seem to get many people who have any optics or photonics skill sets at all.
That's a really interesting, Joel. This is really interesting, you know, problem statement, because, you know, we do see, I mean, we are, in fact, I would ask the folks on the community colleges and institutions, you know, perhaps chime in here, but there are courses that are teaching these. So is there not enough of them, or they're not in the right area, or people not taking them? What do you think is the, or at least, I'm not trying to put you on the spot, Joel.
I personally, I don't know the answer to that. I know that when we post jobs, we end up training on site more so if we find somebody who has similar skill sets or the ability to learn. We do a lot of the training in-house instead of trying to expect somebody to have that skill coming in. So it would be nice if we had, you know, some type of, you know, program where we could get some graduates and point them this way. And if hopefully if we had open positions that we could place them.
This is George again. Certainly, you know, Julie and Anu are thinking, well, there's Stonehill, there's, BSU, definitely talk to those folks. I have another question for you though. How much more do you pay for these specialized skills than you do for the traditional? What are the typical starting wage rates for the two?
So that's a good question. So we are hiring right now some lower level assembly, which we're not expecting to have the skill set. And that's probably around 18 to 20, maybe 21 an hour, depending. Whereas our higher level optical technicians probably make upwards of $30 to $35 an hour, depending on their skill set.
Thank you. So it's certainly an attractive salary.
Yes.
If you can get the skills. Great.
Yes.
Any positions open?
Yes.
So I just sent you my contact information and some.
Thank you. I just got that.
Yeah.
So thank you, Joel. That's really enlightening. I think it almost goes back to the challenge that I mentioned, is that, it's either we're not hitting the mark with the topics that you need, or isn't just available. I don't know what the answer is at the moment, but I do know that there are institutions that are offering those courses, but I just don't know what the missing link is here,
So
I'd be interested to understand what the rate of the students coming out of the program, are they able to get positions?
Joel, we're starting our first year with this photonics program, and we have 12 students who are all searching for internships right now. We do have a lot of companies we're working with, but none of them have committed yet. So we have a handful. I know at Springfield Technical Community College, they have a wonderful program. QCC does, Quinsigamond Community College. I think there's a lot of demand for the students. Our program is a little bit younger, so we're still finding industry partners.
Yeah, and if you look at where Wakefield is on the maps, we'd be looking at UMass Lowell, Middlesex Community College, Northern Essex Community College, and I'm not sure. I'm going to go look and see what their manufacturing curriculum is and whether or not they've got any focus in photonics and optics, because I just don't know off the top of my head. So this is Adrienne from Quinsig.
Great, thank you so much.
So it looked like we might have two other industries who wanted to speak. I believe Andre may be interested in saying something, as well as Christian, because I both saw you take off your mute. So if you have some comments, we'd love to hear them.
Andrea.
Thank you. I'm Andrea. I'm working for Convergent Photonics as a R&D manager. And we have actually two open positions for our production. We are making high power lasers for industry and mid-range power lasers for medical. And we have these two open positions, I guess, unfilled, and we are not receiving resume probably for the last 4 weeks or something like that. Most of the time, when we want to have someone with the good training, usually we are trying to be attractive for other employees from other companies. That is not fair, I think. But this is the only way we were trying to fill this open positions. Because most of the time, what we have as a candidates are not reflecting what the expectation or expertise in optics that we are requiring as a basic skills for testing lasers, for optical safety. And one of the things that I think Randy touched that was not very clear to me, how could you learn a person to be detailed oriented? Because this is something that, of course, is becoming crucial when you start having some issues and you don't need to involve R&D or high-level technicians, but you can try to figure it out by yourself. And this is something, you know, make the people thinking or be creative. This is something that is very interesting, but is not clear to me how it could be trained.
This is almost, Andrea, this is almost going back. These are, and I think again, George touched upon that, some of the soft skills that there is no really, I don't know, but I mean, I'm not an educator, so I can't really comment on that, but I don't know how the certification around those kind of trainings go, and what do you do in order to train somebody to exhibit some of the qualities that you're mentioning here?
It's really tough to certify those. So what we hope to do in this kind of curriculum, and certainly we do it in MIT also, is that it's going to be hard to give you a grade on how well you collaborate with people, or whether you're detail oriented, except that it'll reflect in other things you do. But what we try to do is we try to incorporate opportunities to practice these skills into every other course. So rather than having a course on social skills, we make you collaborate, we make you do presentations, we make you sometimes even sell your idea to other people as part of the other courses. And so if you're going to succeed in those other courses, you're going to need to learn these skills, but we're not going to actually certify you in them specifically. And we can think about the same thing in the Masstech curriculum. To what extent can labs be less about following the instructions and more about actually thinking through how you might conduct the experiment? Or to what extent do the labs have situations where there are things missing and you need to notice what's missing before you can get moving on? I can remember one lab I did back in undergrad. We were just looking at a black box and trying to figure out on its electrical characteristics what was inside. And I was really pretty good at it, but rather than having resistors and capacitors inside, my professor gave me one that had a battery inside. And it had all kinds of weird characteristics, but I forgot to check whether it had a voltage on it. And so, so this kind of thing, what we're hoping to do, this is a long answer, I'm sorry, but what we're hoping to do in this curriculum is, rather than teach the skills specifically, to embed them into the other courses that are being taught.
I want to give Christian, yeah, I think you wanted to chime in, right?
Yeah, no, so I think I also want to second what I heard before, that for specific, for jobs, kind of where some photonics or optics background would be beneficial, it's hard to find a lot of good candidates. So I think that's one thing. That's not generally true, but for I think is kind of the price range where we talk about maybe $30 or something. It's there doesn't seem to be a large pool of candidates at this point. So I was actually happy to hear about all those new programs, kind of through LEAP and others at the community colleges. So I think that hopefully kind of will lead to kind of more technicians graduating in those areas. The other one is a lot of times, especially it's very specialized. So I guess it's hard at community colleges to train the technicians specifically for the job they will have to do at the respective industries or companies. So I think what George also just said, I think is very important to teach them critical thinking, how to troubleshoot. You want to have someone in the lab, even if he doesn't solve or she doesn't solve the problem, recognizes there is a problem and brings it up rather than just keep going on with their work. So I think those soft skills, critical thinking, having a certain level of understanding of what they're doing and then being able to communicate it, I think is also very critical, rather than being an expert of a certain photonics platform, which is, I think, at this level anywhere hard to do. And then also it's such a segmented field, I think that yeah, you cannot train them at the at this stage to be an expert. I think to a certain extent that simply has to happen at the company level.
I think in Quinsigamond Community College, when I visited there, Jacob, if you're still online, maybe Adrian, they actually teach that, where they take out parts of a system and they say, now figure out what's missing. So troubleshooting is a part of their curriculum.
Yeah, no, and I'm sure it's happening already. I'm just saying I think this is very important, and it's true not just for technicians. I think it's true for every level of employees, whether it's engineer or scientist, being able to recognize if there are issues and then being able to communicate them and also collaborate with others, is definitely a critical skill that, I think cannot be stressed enough how important it is, rather than, just focusing on the technical skills.
Okay, so any other comment on this one before we move on?
So just to add, one of the things we're doing, we've been doing some work we call the human skills matrix, where we're trying to understand what are these critical skills to succeed in organizations. And you can Google MIT Human Skills Matrix and you'll see what's there. As part of this, though, we're developing role plays. And so this is another thing we want to link into as an additional training opportunity, because you can do that outside the classroom too. Role plays where you need to make sense of data and help convince somebody of your viewpoint, given a lot of data, some good, some bad. We have one role play where you have to go and convince somebody to do something, and you're a very junior person in the place, and that person's a very, very senior person. And you will not succeed at convincing them to do this. And yet it's surprising to me how many people get in, and the first time that person says no, they don't know what to do. So these kinds of role plays are tremendously useful, and we can think about to what extent they might be useful, both in this Mass Bridge and also in other opportunities.
George, hi. This is Bruce Mendelson.
Hey, Bruce.
Are you referring to the modules that the Gordon Engineering Leadership Program offers, or is this separate from what Gordon offers?
The Gordon is an excellent program. This is separate from that. Certainly, there's a lot to learn from the Gordon side, and also there's just the whole NEET program, NEAT, inside MIT also offers some great stuff. One of the things we're trying to do is figure out where those are and point to all of them, so that we can be one place that points to where these all exist. Thanks for pointing that out.
The role playing is key to, I think, the youth learning.
I think you're right. It's working at all ages, but I agree. It's a very active way to learn, a very engaging way to learn.
All right, so I want to, you can see this question that, so we put up here. I wonder what are the thoughts in here, but as you're dealing with newer technologies, as you're bringing new technologies into companies, what topics you feel that going forward, looking at your own roadmap, where you want to go, what do you feel that there are some of these skills that you value, and then it would be great if we have a ready-made people with those skills that will be addressing your future technologies. I think we've covered some of this already in here. I wonder whether there are some other ones that you're thinking that specifically that hasn't been mentioned or hasn't been talked about here. Okay. So that probably, I think one of the skills that, and there may be another question in here that's later on actually, but I believe some of these questions were, let's see what, okay, this one was more of a general talk. Maybe we should actually talk about this as well a little bit. I think we've heard about, I heard from Scott talking about mechanical people, but any sort of ideas or any sort of comment on this one, which is the most difficult to fill? Now, I believe that you would have a slant towards photonics here because of Photonic Industry Forum, but then maybe, Scott is here, so he can give us his opinion too as well here.
And also if they could even allude to, I know Joel already mentioned it, but how long do these positions sit vacant and for you to fill these types of positions?
Don't be shy.
For us on our engineering team, it's definitely the mechanical position that we are typically searching for. That search typically takes us about, I don't know, anywhere from a month to 3 months to kind of find the right candidate. And we do see employee turnover in this position probably every 2 years, just based on our location of our business.
How do you find the candidates? Is it through Indeed or something like this?
Mostly through Indeed, but we also have good partnerships with some of the local colleges for us in Western New England and even RPI over in New York. WPI as well.
For us, we hire optical engineers, and we have a partnership with the University of Rochester. So we typically don't have much of an issue hiring for the optical, but those are mostly the type of mechanical and optical are the type of engineers we usually hire.
Mm.
Do you hire folks that are maybe trained in industrial or chemical, but they have the right aptitudes?
For us, we don't, because we have a specific need. We do optical design, so we would need optical engineers to do that.
Yeah.
The other question for Had to maybe follow up on is the first survey question or poll question. It kind of split, it bifurcated. They need entry-level positions and they need kind of that advanced manufacturing. So as we think about our training, I mean, we're talking about a statewide system. So we talk about having our entry-level training programs that start with our vocational schools, work through our workforce training systems, and then also some of our community colleges. Is there just a gap that there's not a need for that kind of middle machinist type of position, and you go right into the upper level advanced manufacturing? Just trying to understand that need there.
I mean, I can only speak from our business. We have, we're a little bit unique in that we do a lot of optical design work, which we use our optical engineers for. And then with that becomes prototypes and assembly builds. So we have a manufacturing group that builds those. So it's kind of two separate parts of the business. So our needs are either optical engineers that can design, or hands-on manufacturing technicians that can build.
I see.
Does that answer your question?
It does. And the other groups?
I actually have a follow-on question, Joel. Thank you for providing these answers. Typically, how long does it take your company or for you to get somebody to train to a point where you can now devote it to the application specific stuff?
I think it would depend on the role. If I'm thinking of a technician or assembler, it could take 4 to 6 months before they're fully trained. I mean, I guess it depends on their background and their experience, but it's handling the lenses and the intricate assemblies that we have sometimes does take a while to train somebody.
No, I think the time frame gives us I think one of the challenges for folks that are trying to move from another career to manufacturing is, okay, I'm going to be doing manufacturing, whether it's photonics or whatever. The question now is, how long do I have to train for? You know, if I have to sort of spend 15 to 18 months, that's a big challenge for especially somebody who's got a, you know, got a family, got to make money and whatever it is, you know, it's a lot of commitment. So I'm just trying to compare how that training, the length of training that happens in your company, not in industry, versus something that folks have to go through the training courses at a community college or university.
Would an apprenticeship program work better here, where companies pick the person up and then they get trained with the help of these community colleges?
Yeah.
And we're coming up on time, but I will follow up on that to what Anu just mentioned, is that one of the conversations that has come up as we start talking about curriculum, and even to the conversation today of some of the needs, is that there are certainly things that we will be able to do as we develop this curriculum that will roll out, again, across the state to our community colleges. And we may be able to get to those skill sets that we were talking about, those troubleshooting, those problem solving pieces that can be really collected in that kind of a training. But then it may be that partnering with, again, our mass hires in different groups to look at the apprenticeship model. If we can get those individuals to this level, then when you need to do that specialized training that is going to be very specific to your program, that apprenticeship model could be a pathway that makes sense. And it is certainly one of the areas that we are looking at. So with that, I just want to kind of bring us all back, because we're in the last 4 minutes of the meeting today. So this is just the first of a series of forums, and also you are the third in a series of forums this week that are happening. Each of the forums had a little bit of a different take on focusing on a different one of our Manufacturing USA institutes, and it was really to just do our initial start creating that awareness around the MassBridge program, and really starting to hopefully engage our employers to really be an active member in this process. We also want to be respectful of your time. But as we go through, and as I mentioned in my presentation earlier, we will be collecting feedback from all 4 of these forums. We will be rolling that up into kind of lessons learned of what we heard. That information will be shared with our curriculum folks, but we will also share it back with all the participants from all of the forums. In addition, the reports that Randy and George's teams are working on, they're doing final changes and fixing, I don't want to say fixes, but they're doing those final vetting of their reports right now. Those should be ready at the end of the month. We will be able to share those with individuals. And last but not least, if there's something you do feel strongly about and you want to talk in more detail about it, certainly if it's around workforce skill sets, Randy is happy. I'm speaking on your behalf, Randy, but I believe your team is open to continuing on and having additional conversations with companies who would like to talk more about their needs. And same with George's team, if there are conversations around certifications, around the training types of models that work best for you, we want to collect as much of that information as possible. As I mentioned, the curriculum team will be starting to pull together here in the, starting next week, and they'll be working for the next 4 months on developing the curriculum based on this feedback. But we will probably host another forum, probably to really focus on curriculum in particular, either late in the summer or early fall. We would love, again, for feedback. And so if you are interested in staying connected, we will keep you on the list and keep you engaged. And also, if you are looking for just other information to connect to our whole workforce system, again, the Mass Hire workforce boards are here. They play a key role. We also have the Executive Office of Education who partners with us. So connecting to the vocational systems, to our career tech ed programs. We are really looking at this as a system-wide program. So although MassBridge will be very focused on that advanced manufacturing, if you do have questions anywhere along the that workforce piece, we can certainly help to direct you in that. With that, I will ask Farhad if you have any final questions, and then we'll finish off with Kelly and any final words from the Mass Hires.
No, I don't have any question. I really appreciate all the feedback we've gotten through this process, but I do want to emphasize one thing, that please stay in touch with us. We really look forward to collaboration with you. We want to make sure we hit the mark with this curriculum and the new effort that we're putting into this training. So I encourage you to stay in touch and ask us questions, ask for connections, whatever you feel is appropriate.
Can I make a plug for the awareness? If you have videos or ideas that you want to share that we can bring in more people, please share that with us.
All right, Kelly, I'm going to turn it over to you. Kelly.
She has to unmute her phone.
Oh. Well, okay.
All right. With that, we'll go ahead and call it a day. We thank you for all of your time. And again, if you have any questions, we will send out a follow-up email probably early next week, which will include the PowerPoint presentation today and a link if you want to go back and relive this, this meeting today, we will have a link to that as well. So thank you and have a wonderful day.
Thank you very much, everyone. Appreciate it. Yeah, bye-bye.